All right, so here we go. Get everything away. Phones away. Come on, phones away. Hey, just put that thing away. Oh. All right, so here we go. What I want to do, I want to just finish up these last few. We'll go pretty quick on this though. So we're trying to find the quotient. We're going to simplify this, right? Write your answer as a simplified rational function. So what do? Well, whenever you are, we're just going to follow order of operations, honestly. Whenever you're simplifying something, you're just going regular, top to bottom, order of operations. Okay, so we start off with parentheses. It doesn't look like there are parentheses there, but there are. I want you to kind of think about this for a second. Parentheses, we talked about this earlier in the year, it doesn't just mean parentheses, it means any kind of a grouping symbol. Anything that groups part of an expression counts as parentheses. Well, what does here? Actually, it's this division bar, right? I've got this division bar, and it splits the top from the bottom. So it groups the top all together and the bottom all together. So we always say that whenever you have a fraction, there are always going to be implied parentheses around the numerator and denominator, right? So all we're going to do is we're going to simplify both the top and the bottom, turn them into one big, the top's going to be one big fraction, the bottom's going to be one big fraction, and then what do we do when we divide by a fraction? We flip and multiply, right? So we'll multiply by the reciprocal of the bottom. So what do we have to do in this top one? 1 is the same as 1 over 1, right? So I get 1 over n if I write them, 1 over 1, not x. I'll write both parts as fractions. I get 1 over 1 minus 4 over x divided by x is the same as x over 1 plus 1/5. So let's look at the top fraction. What's the common denominator going to be?
1.
Not 1.
1x.
It's going to be 1x, isn't it? It's going to be x, right? I've got to get an x in the bottom of both of these. Right here, I don't even really have a fraction. It's just a 1, but I can put a 1 on the bottom. So what do I have to multiply top and bottom by there to get an x on the bottom? X. Okay, that's good. That's going to give me then, on the top, that's going to give me x over x minus 4 over x, which is just x minus 4 over x, right? Everybody agree? Okay, what about the bottom? What's my common denominator going to be on the bottom? 5. Yeah, so I just have to multiply this guy by 5 over 5, right? And then what's that give me? On the bottom, I'm going to get 5x over 5 plus 1 over 5, which is just 5x plus 1 over 5, right? Make sense? Okay, so I made the top into one big fraction and the bottom into one big fraction. So I simplified, I did parentheses. Now all I've got to do is flip and multiply by the bottom. Okay, so then the next step would just be from here. The top stays the same, right? But when we divide by a fraction, it's the bottom that gets flipped and multiplied. So we get x minus 4 over x times, when I flip the bottom, I get 5 over 5x plus 1, right? So now I just multiply straight across. So you can, if you want to, I don't even care. You can just leave it like 5 times x minus 4 over x times 5x plus 1. But if we were to distribute, this would just give us 5x minus 20 over 5x squared plus x, right? I just distributed the x all the way through and distributed the 5 all the way through. Right? Questions on that? Okay, is that making sense? It's been a little while since we did one like that, but not so bad. How about this? Find all valid solutions. So when we're solving rational equations, remember all we're going to do is clear the fractions. We're going to multiply both sides through by whatever we need to cancel all the fractions, right? What would be the least common denominator? So what could I multiply everything by here then? So I could cancel, like if I multiplied by x, that would cancel this guy, but it wouldn't cancel that guy, right? X over x squared. So I got to multiply by x squared. Everybody agree that's my LCD?
Yeah.
Okay. Okay, so that's my LCD, right? If I look at all the denominators. So I'm just going to distribute an x squared through to both sides, right? So if I distribute the x squared to the 1, I just get x squared. If I distribute the x squared to the 12, I get 12x squared over x. Well, what happens? What's x squared over x? X, right? So when I distribute it there, I'm just going to get a 12x because one of the x's cancels. And then on the other side over here, Brandon, what am I going to get over here if I multiply this fraction by x squared? Anything cancel?
Cancel the volume.
Yeah, good. The x squareds cancel, don't they? Right? So I would just get a minus 32, right? Now I've got an equation. That's good, right? Now I've got a simple equation. Were there any values, before I move on real quick, were there any values of x I needed to exclude from my original problem? 0, right? Because I've got x's on the bottom. That means x cannot equal 0. We've got to remember that, right? And now we'll solve our equation. As long as we don't get 0 for an answer, we're fine. So Mallory, what do I do when I've got an equation like this? What do I always have to do when I'm going to solve an equation? Set everything equal to 0. Yeah, right. We got to get the whole thing equal to 0. We got to get it in standard form. So I'm just going to add the 32 to both sides, right? So then I get x squared plus 12x plus 32 equals 0. Now that's just a quadratic equation in standard form. What are my options?
Magic numbers.
Magic numbers if possible. What if that doesn't work, Gage? Then what can I do? Quadratic formula, sure, right? Okay, we got this ax squared plus bx plus c equals 0. There it is, right? Okay, this does have magic numbers though.
We aren't doing much.
Well, I would. It's easier.
Imaginary numbers.
Did I say imaginary? Oh, I said magic. Did I say magic or imaginary? I don't know. What is? They sound the same. I meant to say magic. If I said imaginary, sorry, we're not doing imaginary numbers. You're right. I'm going to use magic numbers here, though, right? So what are the magic numbers that multiply to 32 and add to 12?
8 and 4.
8 and 4, good. So then what does that make my zeros? Negative 8. X equals negative 4, right? And if I wanted to, I could check all those, right? Okay? I'm not going to take time to do it. They work. But I could either plug them in, and simplify on paper, or I can use a non-graphing calculator and I could just plug them in and see if they work that way too, right? Let me just show that to you once. Actually, I'll do it later. There's a better one I can do it on later. So those are our answers, right? Those both work because neither one of them is 0. So in Moodle, I would just input my solutions are, I'm going to separate them with a comma, negative 8, negative 4. Okay? How about something like that? Now this shouldn't say proportion. I've changed this so when you see it on the final, it won't say proportion. It's just going to say solve the rational equation or something like that. So it's not a proportion because a proportion means you've got a fraction equal to a fraction. And that doesn't look like a fraction equal to a fraction. Right? So it's not technically a proportion. But what do we do? Same kind of thing we just did. We got to clear the fractions. What do I multiply both sides through by here? 2x, right? I want to cancel everything. So I got to be able to distribute through a 2x. So on the right side, anything cancel? Left side. X's cancel, don't they? So I get the x's canceling, and I just get 2 times 5 is 10, right? How about over here if I distribute that through? Yeah, the 2 x's are going to cancel there, aren't they? When I distribute to this term, I'm going to get 6 times 2x over 2x. So the 2 x's would cancel, and I would just get a 6, right, from this guy. And then here I'm just going to get a plus 2x. Okay? So then what do I do? That's probably back to it. What do I do to solve that? Yeah, there's my answer.
Subtract.
Yeah, so if I subtract 6, I'm gonna get 4 equals 2x, divide by 2, and I get
2.
x equals 2. I could plug it in and check it once
What
again.
does the dark blue say?
That dark blue's pretty hard to see, isn't it? Here, let me do this. Let me do, how's that? Oh, that's bad up there. Here, I'll go, there we go. How's that?
Yes.
There we go.
So,
Is that better?
Would you take the 0 of that, or is that the answer?
Say it again.
Would you take the 0 of that, or is that the answer?
That's the answer, right? Because what happened was when we cleared the fractions, we got this very simple equation, right? And then we were just able to isolate x. We didn't have to factor it or anything, right? We just isolated x. Does that work? Sure it does, because what's the only excluded value?
0.
Yeah, right, we've got an x on the bottom there and there, so x cannot equal 0, so 2 is a good answer. Okay, that's valid. Questions? All right. Okay, what about this? Now, this is a proportion, because it's a fraction equal to a fraction. So I could clear the fractions by multiplying both sides through by x plus 6 times x minus 12. That's going to work. What would happen if I did that? My least common denominator, does everybody see that the LCD of x plus 6 and x minus 12 is the product? X plus 6 times x minus 12, right? They don't share any factors, right? So I could multiply both sides through by that, by my LCD. Now, if I did that, if I multiply the left side by that product, what's going to cancel? What would cancel if I multiply 2 over x plus 6 times x plus 6 over x minus 12? Everybody agree the x plus 6's would cancel?
Yes.
Okay, so on this side then, I would just end up with, on the top, the only thing left would be the x plus, or x minus 12, and the 2, right? The x plus 6's would have canceled, so I would have gotten this. We good? Okay, what about the other side? Justine, what's going to cancel on the other side? If I multiply this fraction, 6 over x minus 12 times this whole thing, what's going to cancel? So if I were to do this, like I've got my, here it is, if I were to multiply the top and the bottom by x plus 6 times x minus 12, what? Yeah, the x minus 12s would cancel there, right? And so this one would just be 6 times x plus 6. Let me write that up there too so you guys can see that on the notes. Right, and those cancel, right? That makes sense? And now we could just solve this. Well, this is a trick that you guys learned in a different form a long time ago in Algebra 1. There's a shortcut for proportions. What do you do to solve a proportion from Algebra 1? If I have a fraction equal to a fraction. What do you do? Cross multiply, right? Well, look what happens here if I go back up and I cross multiply. So I'm gonna, let me do this. I don't want that to, oh man. Here, I'm gonna do this. So look what happens here if we just, instead, if we just cross multiply, what is that? Well, that's going to give us the cross products. I'm going to get x plus 6 times 6. Well, when I multiply x plus 6 times something, it means the quantity, right? It's the whole thing. So I've got a 6 times x plus 6 equals this cross product, 2 times x minus 12. Does that look familiar? Same thing we have right there, isn't it? Right? So all I got to do is solve that. I could just distribute the 6. Brandon, what do I get when I distribute 6? 36, good. Equals, what about this side? 2x minus 24. Good, so then I'm just going to push the x's which way?
To the left.
To the left. Okay, so I'll subtract 2x, So I get the x's off the right, so what way do I wanna probably push the numbers then? To the other way, right, so we'll subtract 36, and what do I get if I do that? So I get
You get, 4x.
4x
minus
equals,
12. Is it negative 12?
let's see, so I'm gonna get, I'm subtracting these, so
Oh,
negative
so you divide
60.
by-
So what's my answer then?
It's 15.
Negative
Oh, it's
15?
negative 15, yeah.
How would I check it? I'll just plug it in. Does it work? Let's try it. So if I plug that in, I get 2 over negative 15 plus 6 is what? Negative 9? Is that equal to 6 over negative 15 minus 12 is negative 27? Well, let's see. That means this guy simplifies to just negative 2/9.
Alright, 2/9.
And then this is 2, isn't it? This just equals negative 2/9 if I divide top and bottom by 3. Right? Okay, so it works. So it checks. Okay? Good? Yes, ma'am.
Any question?
Yes, you may. Solve the rational equation. Okay, so what about this guy? Same kind of thing, right? This is a little harder though on this one. This time the LCD is a little bit bigger than it was before, but it's not terrible. We have to factor everything to begin with, right? So the very first thing we got to do is we're going to take this first fraction. It's already done. It's already factored. Second fraction is also factored. Let me do. What about this last one? I'm going to spread them out so I can multiply everything, I can distribute the LCD through. That's all the reason I'm spreading them out so much. Minus 4 over, what's that factor into?
Factors into
X minus 5,
X minus 6.
X minus 6, okay? So what's the LCD, Caitlin, what's the LCD of the factors X minus 5, X minus 6, and the product of X minus 5 and X minus 6? What do you think? What's the smallest product I can build so that I'm going to include that factor and those factors? There it is, X minus 5 times X minus 6, right? Okay, so we know okay, good. So then what's that tell us about answer to number 1? What are the values of X that have to be excluded from the domain? Not 0. Okay, I've got these are the factors in the bottom, right? So we're going to have X cannot equal 5 and X cannot equal 6, right? So it just wants a list of them here, so I would just put 5, 6, right? Okay, now we keep going. We're going to multiply, we're going to clear the fractions by multiplying both sides through by that, right? So we get X minus 1 times X minus 5 times X minus 6 equals negative 7 times that product minus 4 times that product. Okay, so what cancels? Okay, so in the first one, the negative 5's cancel, leaving me with X minus 1 times X minus 6. What cancels here? The X minus 6's, leaving me with negative 7 times X minus 5 minus everything but the 4. Good, so just minus 4, right? And now I'm just going to solve that equation. Well, what do? I just got to get it all, I've got to multiply everything out and put it all on one side, set it all equal to 0, right? And then I can either factor it or use the quadratic formula, right? So over here, if I multiply that out, if I distribute the x through, I'm going to get x squared minus 6x. Let's kind of combine our thinking here, though. when I distribute the negative 1 through, I'm gonna get a negative 1x, right? So negative 6x and negative 1x is negative 7x, right? And then finally, when I distribute the negative 1 to the negative 6, that multiplies to positive 6, right? Okay, so there's the left side. What about over here? If I distribute through negative 7x plus 35 minus 4. Okay, Casey, which side am I going to push everything? How come? Okay, I've got a. Do you see any x squareds up there?
Yes.
There's an x squared. We want that to be positive, don't we?
Yeah.
So we're going to leave it over there, right? Okay, but you see something going on, don't you? If I add 7x to both sides, what's going to happen?
Cancel.
They're going to cancel, aren't they? I've got a negative 7x on both sides, so those cancel. That helps. Then what are we left with? I've got x squared plus 6 equals 35 minus 4 is 31, yes. Okay? It's a weird answer, but that's all right. We'll go with that. So if actually, no, it's not. It's going to work fine. So now what do I do to get the x by itself? I've got a single x that I can point to. So go ahead.
If you're subtracting 6 from 35, why would it be 31?
It's not. I combined these two.
Oh,
Right. 6 is still over on this side. So now if I subtract 6 from both sides to get the x by itself, I get x squared equals 25. So what's x equal to?
Plus or minus 5.
Plus or minus 5, right? I'd get a 5, or x equals negative 5. Are those both okay?
No.
Minus.
5.
5's no good. 5's excluded, right? So we got to go down here, and that one we can't use. This one we can, and so our answer is, for part 2, is just negative 5. Okay? Good?
Yeah.
Okay. Okay, so what about this? Simplify the expression. Okay, we can do this. I showed you guys a great trick for this, right? Say it again. Yeah, we do, exactly. What we want to do, our goal, what do we want our answer to look like? We want our answer to look like this. It's going to look like some stuff that's outside the radical times some stuff that's inside the radical, right? We want to get as much out as we can. So we're just going to break this into 2 pieces. We want to break this into the 20 part, right? So we're going to simplify the square root of 20. How can I break that into the product of a perfect square and then a leftover? So what's it going to be? 20 is what times what? 4 and 5, right? 4 is a perfect square, so that goes first. So square root of 4 times square root of 5. We circle the perfect square one because that becomes
2 out of 5.
Good. And so then we end up with the 2 is outside and the 5 is inside, right?
And that's it?
Not quite. Not quite done. Now we got to deal with the x squared part, or the x to the 5th part, right? So we have to simplify. We have to simplify the square root of x to the 5th, right? Here's where, what do we do, Gage? You remembered this. This is good. What do we do? How do I rewrite that? What's the index of the radical? If it's a square root, what's the number that actually, it's invisible, but it sits right there? 2, right? 2. If it's a cube root, it's a 3, and then we write it. If it's a 4th root, it's a 4, and then we write it. But we get lazy with the square root. It's actually its second root, though, right? So then if there's an invisible 2 on the top there, I'm going to write that as a fractional exponent. So which part goes where? I've got a 5 and a 2. 5's on the top, 2's on the bottom, right? So x to the square root of x to the 5th is equivalent to x to the 5 halves. Remember what the trick is, really simple. All we're going to do is we're going to write this as a mixed number. We write the exponent as a mixed number, and the integer part goes out front, and the fraction part is the part that's stuck in the radical, right? So what is 5 halves as a mixed number? 2.5. So we get x to the 2 and 1/2, right? And so that means that we get out front, we get the x squared. Inside, we get an x, well, it has to mean 1/2, right? So that's gonna be an x to the 1/2, right? But we don't write the 1 and the 2, right? For a square root, we don't actually write that. And we don't actually write that. So our final answer would just look like, outside we've got our 2x squared times the square root of 5x.
Is this stuff on the final?
I gave you guys a bunch of harder ones like that, where I gave you, remember I gave you like x, y's, and z's in there, right, early in the year, okay? So this only got one variable, no big deal, right? What about something like this? Okay, same kind of thing, right? This really is almost no harder. What do we do when we're trying to simplify a radical when it's a square root of a fraction? Well, the first thing we want to do is look inside, look at the fraction and see if you can reduce it. And do that first. That makes it way easier, but unfortunately we can't do that here, right? But then we're just going to split this up into, split the top and the bottom, and simplify as much as you can, and then we just have to rationalize the denominator, get rid of any stranded radicals, right? So that's our goal. Split the two, simplify both, and if we end up with a stranded radical on the bottom, we got to get rid of it. That's it. So on the top, we get the square root of 20 x to the 7th. On the bottom, we get the square root of 7y. So what about the top? We already did a 20, right? The square root of 20 breaks down into what? 2 radical 5. Good. Okay, now what about the x to the 7th? That's the square root of x to the 7th is just x to what power?
7/2.
7/2. What's 7/2 as a mixed number?
3.5.
So we end up with an x cubed out front and an x to the 1 inside, right? Whatever the leftover, whatever the remainder is, the numerator is how much is stuck inside the radical. The denominator is just telling you what kind of root it is, square root. 2 goes for square root, right? We got that. What about the bottom? We can't simplify the bottom, can we? Right? Nothing, there's no perfect square factor of 7. And if you think about y, look at the fraction there. Y, the square root of y is just y to the 1/2. Well, there is no integer part of that. It's a proper fraction. It's less, the fraction is less than 1, right? So we can't even write that as a mixed number. So on the bottom, we're stuck with the square root of 7y. But what's our rule? When we're trying to get a square root out of the bottom, what do we do to the top and bottom? Well, meaning we multiply by the stranded radical, right? On the bottom, we've got this stranded radical, the square root of 7y. So we're just going to multiply both the top and the bottom by the square root of 7y. Well, what's that give us? On the bottom, if I multiply a square root times itself, it just undoes the square root because I'm squaring, right? So on the bottom, I've got a 7y. Out front, I've got a 2x cubed. And what about in here? I'm just going to multiply those square roots together, right? The square root of 5x times the square root of 7y is just the square root of 5 times 7 times x times y in any order. Well, what's 5 times 7?
35.
And then just an xy, right? So that's our answer. Okay, good? All right. How about something like that? That looks complicated because they're fractional exponents, but it's not. It's just properties of exponents. Right? All we do is subtract them. 5/8 is bigger than 1/3, isn't it? So what's our rule then? If the top power is bigger and they're like bases, I leave the base on top and subtract the bottom exponent. So all we end up getting here is just, we get v to the 5/8 minus 1/3 to that power. I just have to add or subtract those fractions. What's the common denominator of 8 and 3?
Well, you're just kidding, 8 doesn't go to 8.
24. Good, so I'm going to multiply the top and bottom of the first one by 3, right? Second one by 8. So I end up with v to the 15/24, right? Minus 8/24. So what's the exponent then? 7/24. Okay? You good? Okay. All right, done with that guy. Last couple, this one's actually really simple. All I'm gonna do is distribute. If I distribute the square root to both parts, what's the square root of x times the square root of x? X. Square root of x times -5 is just -5 square roots of x. What if I distribute the -9 to both? I get -9 square roots of x plus 45. And so if I combine like terms, everybody agree those are actually like terms? Because I'm multiplying a number by the same power of a variable by a square root. So I end up with x. What's -5 of something minus 9 of something? Minus, not times. Minus 14 of whatever you're adding up. Well, these are just square roots of x, right? Plus 45.
And that's it?
That's it. That's it. Okay, last couple is the last 3 or 4 problems, and we're done. And then Monday, you guys can just plow through this stuff. Remember, final can only help you, but it could help quite a bit. It's gonna be worth more than a regular test, so it could pull your grade up significantly. All right, so what about this? What do we do when we have a radical equation? The rules are simple. All we do is we isolate the radical, already done. I mean, it's by itself on one side of the equation. And then you take both sides to whatever power you need to undo the radical, right? So we square both sides. Right, so we end up with, whoops. We're just gonna square both sides. What do I get on the left side?
X plus 1.
X plus 20. On the right side?
40.
So what do we get?
29.
29 if I subtract 20. Okay, but I gotta check it. If I take both sides of an equation to an even power, so if I square both sides, I could introduce false solutions, extraneous solutions, so I gotta check it. If I plug that back into the original, what do I get? Square root of 29 plus 20, is that equal to 7?
Yes, we have to add it.
It is. Square root of 49 is 7, so it checks. So that's our answer. Okay. Same kind of thing here. This time, this looks harder, but it's no harder. It's probably even easier. All you're doing is you're just going to square both sides, right? I've got radicals on both sides by themselves. So if I square both sides, it just undoes both radicals. And I end up with 4x plus 1 equals -6x plus 10. Add 6x to this side. Subtract 1. Oops, yeah, that's right. 10x equals 9, so what's x? 9/10. Okay, good. I want to check that, but that's kind of hard to check, right? All I've got to do then is put it in a calculator, see if the decimals match up, right? I could say, what is this? If I'm plugging in 9/10, I'd get the square root of 4 times x is 9/10. Anytime you put a fraction into a calculator, just put it in parentheses and you can't make a mistake. So I've got 4 times, in parentheses, 9/10 plus 1, all under a square root. It gives me that decimal, 2.1447, blah, blah, blah. If I do the same thing on this side, square root of -6 times the 9/10 in parentheses plus 10, all under the radical, I get the same decimal, so it works, right? That make sense? That solution made that equation true, so it checks. Okay, what about this guy? This one's a little bit harder. It looks, I mean, it's a little harder. I'm going to square both sides. What happens when I square both sides this time? So I square that side to undo the radical. On that side, I've actually got to square it out, right? I can just use the pattern, though. Remember, we've got the pattern. A plus B squared equals
A squared
plus,
2AB plus B.
Okay, so A is like X, B is like 5, right? So I just get 6X plus 37 equals A squared is just X squared. 2AB is just gonna be 2 times X times 5 is 10X. And B squared is just 5 squared, which is 25. Or I can just multiply it out. X plus 5 times X plus 5.
5.
All I gotta do is just set this equal to 0 and solve, right? So I'll subtract 6X, subtract 37, and what do I get? X squared plus 4X minus 12 equals 0. So what's that factor into? What, X plus 6? X minus 2, right? So what are my zeros then?
-6 and 2.
Okay, but now watch this time, right? We get -6 and X equals +2, but we gotta check this. So we gotta go back to our original problem. Let's see here, if I do this, let's check that in the original problem, right? So what if I plug in -6? If I plug in -6, I'm gonna get the square root of 6 times -6 is 36, -36. Square root of -36 plus 37 equals -6 plus 5. Well, that gives us 1 equals -1. False, right? False. So what's that tell us?
-6 is not, isn't excluded.
That's excluded, right? That doesn't work. Well, it's not excluded, it's a false solution. If we try 2, let's try 2. See if that works. If I plug 2 in, I'm gonna get the square root of 6 times 2 is 12. Plus 37 is 49. Is that equal to
Yes.
2 plus?
7.
It works, doesn't it? Square root of 49 is 7. So that one checks. Okay, last one, and we're done. I know, but I'll just do one more. And then this is the whole, we've done the whole practice test. I'll put all this stuff online immediately before I go home. And you guys can look at this stuff over the weekend if you want to, right? If you want to get ready for this final. So here, same thing. I'm just going to square both sides. I'm going to go a little faster on this one because I only have a couple minutes.
Okay,
Pressure's on. So over here on the right side, I'm squaring a square root, and so it just cancels it. That's good. Over here, we just get plain old x plus 12. But what about over here? I've got something like a plus b squared. So that's a squared, square root of x plus 5 squared, plus 2ab. Well, there's a and there's b, so that's 2 times square root of x plus 5 plus b is 1 squared is 1. Or I could just set them next to each other, multiply this whole thing by itself, just distribute if I want to, right? Well, this cancels the radical, and so I end up, what do I get on this side? X plus 5 plus 1 is x plus 6, plus I've got that whole thing right there. 2 times the square root of x plus 5. Okay, we can, that looks pretty bad, but something important happens. What cancels on both sides? Do I have anything I can subtract away from both sides? The x, yeah, look at that. The x subtracts away. And then what do I end up with? I get 6 plus 2 times the square root of x plus 5 equals 12. What do I do to isolate the x?
Subtract 6.
Subtract 6. That gives me 2 times the square root of x plus 5 equals 6. Divide by 2. So I get square root of x plus 5 equals 3. How do I undo the square root?
Square.
Square it. That cancels the radical, so I get x plus 5 equals 3 squared, which is 9.
4.
Subtract 5 and get x equals 4. We got to check it. So we go back up to the top. Does it work? Let's try it. So I get the square root of 4 plus 5. What's that? So that's gonna be a 3, right? So 3 plus 1, is that equal to the square root of 16? Yeah, 3 plus 1 is 4, it works,
Okay.
when I check that one. So, phew, get one answer. Wow, that's a lot of math, and what about that, 45 minutes worth?
Not coming back.